Let's read the question. The body mass index of a group of male workers is normally distributed, and Table 1 sorts everyone into 4 weight categories. Here is what we are told. 44% are underweight or normal weight, 12% are obese, and 1 out of every N workers is underweight. And our job is simply to find the value of N. Let's write the givens as probabilities. The chance a worker is below a B, M, I of 25 is 0.44. The chance of being obese, at or above 30, is 0.12. And the chance of being underweight, below 18.5, is 1 over N. That last one is what we are after. Let's picture it. A normal distribution is a symmetric bell curve. Every percentage in the question is just an area under this curve. 44% sit to the left of a B, M, I of 25, the underweight and normal weight workers together. 12% are obese, the tail to the right of 30. And the underweight group, the one we want, is this small tail below 18.5. Its share is 1 over N. Here is the plan. To turn an area into a z-score, we need the mean and the standard deviation. We don't know them yet, so we'll set up 2 equations from the 2 areas we do know and solve for them first. Step 1. Build an equation from the 44%. We start with the chance of a B, M, I below 25 being 0.44. To use the table, we standardize. Turn the B, M, I into a z-score by subtracting the mean and dividing by the standard deviation. So standardizing 25 gives this. Here is the part to watch. 0.44 is less than a half, so this point sits to the left of the mean. Standard normal tables only list positive z, so we look up the area 0.44 and read off where it lands. Z equals 0.15, about 0. 151. But our point is on the left, so the table only gives the size. The sign is negative. That is why the z-score comes out as negative 0.151. That gives our first equation. Call it equation 1. Step 2. Now an equation from the 12%. 12% are obese, at or above a B, M, I of 30. The table works with the area to the left, so we take the complement. The chance of being below 30 is 0.88. Standardizing 30 the same way gives this. This time the area is more than a half, so the point is to the right of the mean and the z-score is positive. The table gives 1.175. That is equation 2. Step 3. Solve our 2 equations together for the standard deviation and the mean. From equation 1, make the mean the subject. And do the same with equation 2. Both expressions equal the mean, so set them equal to each other. Collect the sigma terms and the numbers, and the standard deviation comes out at about 3.771. Put that back into either equation, and the mean is about 25.57. Step 4. Now find the chance of being underweight below 18.5. Standardize 18.5 with our mean and standard deviation. The z-score is about negative 1.875. The z-score is negative again, so we use symmetry. The left tail past negative 1.875 equals the right tail past positive 1.875. Looking up 1.875 and subtracting from 1 gives 0.0304. Step 5. Finally get n. 1 out of n workers is underweight, so 1 over n is exactly that probability, 0.0304. Flip it over, and n is about 32.9. Since n counts whole workers, we round to the nearest whole number, so n is 33. To recap, the standard deviation is about 3.771 and the mean about 25.57. The underweight probability works out to 0.0304, and since that equals 1 over n, the value of n is 33.